Foundations of Math 2, Unit 6, Area and Perimeter. The perimeter is the sum of the measures of the sides of a polygon. So whatever shape it is, it's the sum of the sides. For this one, to find the perimeter, we need to find the value of x. To find the value of x, we're going to have to use the Pythagorean theorem. This is a right triangle. So the Pythagorean theorem, which we will use a lot, is a squared plus b squared equals c squared. When you have a right triangle, your legs are a and b, and your hypotenuse is c. So we have 5 squared plus 7 squared has to equal x squared. 5 squared is 25, 7 squared is 49. 25 plus 49 is 74. To undo the squared, you have to take the square root of both sides. So the square root of 74 in your calculator is 8.6. So now to find my perimeter, I have to add up all of the sides. The perimeter is going to equal the 5 plus 7 plus 8.6. 8.6 plus 5 plus 7 is 20.6. And we are in centimeters. Perimeter is linear. That means that it's not centimeters squared or centimeters cubed. It's just whatever your unit of measure is. The perimeter of this one. So we have a rectangle and 2 right triangles. We know they're right triangles because of these right angles that are denoted here. This is 7, this is 24 because this is a rectangle that makes this 16. Since these are noted that they are congruent, this here is also 7. So to find our sides, we're going to use the Pythagorean theorem again. I'm going to call it x. So we'll have 24 squared plus 7 squared equals x squared. And I'm just going to plug that in my calculator. 24 squared plus 7 squared is 625. Take the square root of both sides, or the square root of 625, and you get x is 25. So I have 25 here and 25 there. The perimeter, I just add up all the sides. So I have 16, 25, 7, 16, 7, and 25. Going all the way around. So my perimeter is 96 centimeters. The next one, we know that everything with the 2 dashes, 2 markings are congruent, and everything with the 1 markings are congruent to each other. So all of these bigger sides are 4, and all of these smaller sides are 2. So we have 1, 2, 3, 4, 5, 6, 7, 8 2s. So we can say 8 times 2. And we have 1, 2, 3, 4 4s. So our perimeter is the sum of all the sides. So we have 16 plus 16. So my perimeter is 32. Area is the number of square units contained in the interior of a polygon. So there are different formulas for different areas. We have the area of a triangle, area of a rectangle, a parallelogram, a trapezoid. This is missing the diagram. Our height is this number here. That's our height, what's perpendicular to the base. Base 1 is the top, or b sub 1, and base 2 is the bottom. The area of a kite or a rhombus is going to be the multiplication of the diagonals divided by 2, or half of the diagonals. So this would be D1. And then this whole thing, this whole other one would be D2. So half of the product of the diagonals. So we're just going to practice finding the area. The area of the triangle. So what we need to find here to find the area is this base. We have our height, but we need to find the base. We can find the base because we know these two things are congruent and using the Pythagorean theorem because of this right triangle. So I'm going to call this x. So we have x squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. Subtract the 144 from both sides, and you get 25. Take the square root of 25, and you get 5. So since this is 5 and this is 5, then our whole base is going to be 10. So my area is going to be 1/2 my base times my height. So 1/2, 10 times 12 is 60. And I'm just going to give this a unit, 60 inches squared. Area is always a two-dimensional measurement, so that's going to be squared. Find the area of this triangle. So this one, we don't have the height. The height is out here because it's what's perpendicular to the base. We have our this, but we do not have our height. And we also need to find our base here. So we can do that after we find our height. So I'm going to first find my height. I'm going to call that A, or we'll call it H. My height is h squared plus 3 squared equals 5 squared. We've got this little right triangle here. So h squared plus 9 equals 25. Subtract 9 from both sides, h squared equals 16. Take the square root and you get h equals 4. So our height of this triangle is 4. Well, now we can find our base. I'm going to call this whole thing x. I'm going to just call this B for base. To find our base, we have to first know this whole thing. That's what we're going to be able to find. And then we'll subtract 3. So we can use this whole thing as a right triangle here. So x squared plus 4 squared equals 8 squared, the whole right triangle. X squared plus 16 equals 64. 64 minus 16 is 48. Take the square root of both sides, the square root of 48 in your calculator is 6.9. So the whole thing is 6.9. So the base, I'll subtract the 3 from the 6.9. So 6.9 minus 3 is going to be 3.9. Now I can find my area of my triangle using my base and my height. So my area is 1/2 3.9 times 4, which is 7.8. And I'm going to say centimeters this time, centimeters squared. The area of a parallelogram is your base times height again. So this one, I already have my base, I have my height, so my area is going to be 4 times 6, which is 24. We'll call this one meters squared. The next one, we have to find our height. So because this is a parallelogram, this is equal to 6 root 3 as well. We have our base is 10. So we're going to find our height using the Pythagorean theorem. So 3 root 3 squared plus our height squared is going to equal our 6 root 3 squared. Don't let that root 3 freak you out. It is just another way of writing a number. It's the more exact way of writing it. You're just going to square the whole thing and you can plug it straight into your calculator. So you've got 3 times the square root of 3 squared, but you have to put the whole thing in parentheses, which is 27. And then 6 times the square root of 3 squared, which is 108. Subtract 27 from 108. You have h squared is 81. Take the square root. Your height is 9. So now to find my area, I'll multiply my base times my height, which is 10 times 9, or 90. And I'm going to go with yards squared this time. It will give you a unit of measure. I just want you to get in the habit of making sure you put the units on the end. The area of the composite figures. So here we've got a rectangle and a triangle. Okay, so we're going to create this because these guys are parallel. We know that they're going to have the same angle measure there since this is perpendicular. So we're creating that perpendicular line, which makes this a right triangle. So we can find our hypotenuse of that right triangle, which we don't really even need. All we need is the area of this rectangle and the area of that triangle and add them together. So this rectangle, the area here is going to be 9 times 8, which is 72. The area of this triangle is going to be half to my base times height. My base is 9. My height, though, is not this whole 18. It is going to be 18 minus this piece because we already found the area of this guy. So if this is 8, then that makes this height 10. Half of 9 times 10, which is going to be 45. So then we'll add them together. 45 plus 72, which is 117 inches squared. The next one. The area of the trapezoid. All right, so what we've got here is our top base. The formula for the area of a trapezoid is our top base, which is b sub 1, plus our bottom base, which is b sub 2, all divided by 2, times our height. So I'm going to, my top base there is 12. My bottom base is this 15 plus 3, which is 18, over 2, times my height, which is right here. So I need to find my height. So I can find my height using the Pythagorean theorem. So I have h squared plus 3 squared is going to equal that 6 squared. You have h squared plus 9 equals 36. Subtract your 9 from both sides, and you get 27. Take the square root of both sides. The square root of 27 is 5.2, roughly. So then we're multiplying this by 5.2. So now I'm going to plug that into my calculator. I have 12 plus 18 divided by 2 times 5.2. Oops, 15 times 5.2 is 78 centimeters squared. The area of the kite. So remember that's your A is 1/2 P times Q, or your diagonals, the product of your diagonals. So our whole diagonal here is 6, and our whole diagonal here is 4. 6 times 4 is 24, divided by 2 is 12, and I'm going to call these inches squared. The last one here, before we do a couple of the shaded region, the last one here, our diagonal this way is 8. This is a kite. The formula for the kite and the rhombus are the same. This one was probably a rhombus. 1/2 times my diagonal, which is 8, times this diagonal, which is 12, 10 plus 2. 8 times 12 is 96. Divide that by 2, and you get 48. So we have 48 feet squared. We're going to do a few, find the area of the shaded region. To find the area of the shaded region, you have to find the area of the whole thing and subtract the part that is not shaded. So I'm going to find the area of the square, and that is going to be 10 times 10, which is 100. And then I'm going to subtract that, so the square minus the triangle. The area of my triangle is 1/2 my base, which it says is 6, times my height, which is the side of my square, which is 10. 6 times 10 is 60, half of that is 30. So I've got my area of my shaded region is 100 minus 30, which is 70 inches squared. The area of the shaded region here, I need to find the area of my whole rectangle and subtract the rectangle on the inside. So the area of my whole is going to be 8 times 7, which is 56. The area of the inside is going to be 8 times 5. Oh, I'm sorry, not 8. 6 times 5, which is 30 feet squared. So then I'll subtract the area of the whole minus the area of the inside will give me the area of the shaded region. So 56 minus 30 gives me 26 feet squared. The next one, the area of the shaded region. This one's going to be a little more difficult because what we have to do is we'll have to find the area of these triangles here. So the area of the whole thing is 12 times 12, which is 144. So the area of the shaded region, or what I can do is find a side here, each of these sides, and we know that they're the same because they're all, this is a square, so this one that's turned is going to also be a square. Since the whole thing is 12 and this piece is 9, that makes the smaller piece 3. So we can use the Pythagorean theorem. 3 squared plus 9 squared has to equal c squared. So 9 plus 81 equals c squared. 90 equals c squared. The square root of 90 is 9.5 roughly. So since that's this side, the area of the shaded region is going to be that 9.5 times 9.5, or 90. So when if you round it, then you get the 90.25, but because we know that c squared was 90, that's what it's going to be. So we're going to say inches squared on this one. So you didn't even really have to find the area of the whole thing. The area of the square, the radius there is 2 times the square root of 2. So that's this side here. We're going to skip this one and come back to one like this on the day that we do circles, because we have not done area and circumference of circles yet. So we're going to skip this guy. on the back, a couple area of the composite shapes. Composite shapes just means shapes that are put together. I'm going to do this one. And then the other ones are listed on the key online. They would have been practiced had we been in class. So here I'm going to find the area of this guy, which is 5 times 2, which is 10 because it's a rectangle. We have 10 centimeters squared here. This one, because this is 5, that makes, then this whole side is 9. If we subtract the 5, that makes this 4. So 4 times 8 is 32 centimeters squared. Since this is 2 and the whole thing is 8, 8 minus 2, that makes this base 6. Again, this was 4, the whole thing is 9, so that is 5. So the area of that triangle is 1/2, 5 times 6. 5 times 6 is 30. Half of 30 is 15. So then we'll just add all those together. 15 plus 10 plus 32 is 57 centimeters squared.